Nandita Sanyal. Today I will be discussing mapping of S-plane with Z-plane. Mapping of S-plane with Z-plane. S is a complex operator is equal to sigma plus j omega, where sigma is the real part and omega is the complex frequency part, and S operator is applicable for continuous domain signals. Continuous signals we can use S operator, and if we plot this sigma and j omega in a two-dimensional plane, sigma in the x-axis and j omega in the y-axis, this plane is known as S-plane, and it is very much important to know the location of the poles and zeros in the S-plane to find out the stability of any system. So according to the control theory, if the poles are situated in the left half of the S-plane, the system is stable. If the poles are situated in the right half of the S-plane, the system is unstable. And if the poles are situated on the imaginary axis, then the system is marginally stable. If this concept is applied for a discrete time system, then we need another transform that is called Z transform, and which is applicable for discrete signals. This is applicable for discrete signals, and Z is given by e to the power s tau, where tau is the sampling frequency, where tau is equal to sampling rate. Sampling rate is equal to Z mod Z angle of phi in polar form, where mod Z is equal to e to the power of sigma tau and phi is equal to omega tau. So, Z can be represented as mod Z cos omega tau plus j mod Z sin omega tau. Or we can also write it in Cartesian form as u plus jv. And if this is again plotted in a two-dimensional plane, u in the x-axis and jv in the y-axis, then this will constitute another complex plane that is called Z-plane, and this plane, then e to the power of sigma tau will be greater than 1 and mod Z will be greater than 1. And case 3, when sigma is equal to 0, then mod z equal to 1. So if these three cases is considered in this plane, then we have to draw a circle with unit radius. And the case 1, when mod z is less than 1, that means it will be inside this circle, and when it is mod z greater than 1, that means in the S-plane it will be right half of the S-plane, which represents the exterior part of the unit circle. Exterior part of the unit circle. And most importantly, this imaginary axis where sigma is equal to 0 will be represented by the periphery of the unit circle. So periphery of the unit circle represent mod z equal to 1, that is sigma equal to 0. Exterior part of this unit circle represents mod z greater than 1, that is sigma greater than 0. And interior part of this circle represents sigma less than 0, that means mod z less than 1. So, the location plane can be directly mapped to the z plane, and we can find out the stability of the system in discrete domain. So, left half of pole in the left half can be placed in the interior of the unit circle. Poles in the right half can be mapped in the exterior of the unit circle, and the poles on the imaginary axis will be placed at the periphery of the unit circle. This is the mapping of S-plane into the Z-plane.